All right, so in this section, we're going to learn about the chain rule. So we're going to learn another rule that will allow us to take the derivative of a different kind of function, meaning a composition of functions. Okay, so far, why am I doing that? So far, we've learned how to take the derivatives of functions that are sums of functions that are differentiable, so f plus g, f minus g, so a difference of functions, a product, f times g, and the quotient, f over g. We learned the rules that allow us to differentiate functions like this. So now what we want to learn is a rule that allows us to take the derivative of a composition or composite of functions, okay? So, the chain rule. If f is differentiable, or f is a differentiable function of g of x, and g of x is differentiable, then f of g of x is a differentiable function of x. So in other words, that means that f of g of x prime is equal to f prime of g of x times g prime of x. So in other words, what we do here, whenever you're taking the derivative of a composition of functions, you take the derivative of your outer function, leave your inner function fixed, and then multiply that result by the derivative of your inner function. One more time. F of g of x prime is equal to f prime of g of x times g prime of x. So we take the derivative of your outer function, leave your inner function fixed, then take that result and multiply it by the derivative of your inner function. Okay? All right, so let's look at examples. Let's look at some examples. Our goal is to find the derivative, okay? So remember, let's just recall our rule. Does it help to write that up there so you can see it? Or you want to just refer back? Right. Yes? Okay, so let's recall that f of g of x prime, or we can just put prime, is equal to f prime of g of x times g prime of x. Okay? So, what is our outer function here? Yes. The squaring function. Very good. So that means, and you can just watch and then you can write down if you're visual. That means we bring down the 2, leave 3x minus 1 fixed, raise that to the 2 minus 1. Then we multiply times the derivative of the inside. So that would be equal to 2 times the quantity 3x minus 1. Raised to the first power is just the quantity 3x minus 1, times the derivative of 3x minus 1. What's that? 3. So you multiply that by 3, and then that gives us 6 times the quantity 3x minus 1. And this is your answer. Alternatively, you could go ahead and distribute the 6, and you get what? 18x minus 6. So either answer is acceptable. Very good. What questions do you have? Yes? How did we get 3? Because we took the derivative of 3x minus 1. So the derivative of 3x is 3. The derivative of negative 1 is 0. The derivative of negative 1 is 0. Remember, the derivative of constants are 0. What other questions do you have? Good questions. Do part B. So I've given you g of x equals the quantity 1 minus x raised to the negative 1. I want you to find the derivative g prime of x. What do we get here? Yes.
Can I
Eli?
start from the beginning again?
You can go ahead.
So bring negative one down
So you have -1. Go ahead.
times the 1 minus x,
Mm-hmm.
which is -2,
Good.
and then times -1.
Times -1. Very good. Because that's the derivative of 1 minus x. And then what do we get?
1
Mm-hmm.
times 1 minus x to the -2.
Good. So we just get 1 minus x to the -2 because -1 times -1 is 1. You got it. Very good. What questions do you have? Yes?
Would you want that made into like exponents positive or no?
You could write that. It's a good question. You could rewrite it. And that leads to part C. Yes, you could rewrite it. If you rewrite it, what would it look like?
1 over 1 minus x.
Very good. So either that or this is acceptable. You have to be able to identify both. It's a good question. What other questions do you have? Okay, good. So that leads us to part C. It's a good question that leads us to part C. Part C has h of x equals to 1 over the quantity x plus 1 squared. You could either, as it is given, use what rule? The quotient rule, or you could do what? Say it again.
Like make the exponent negative.
So rewrite it as what?
The quantity x plus 1 to the -7.
You got it. And then you could use the chain rule instead of the quotient rule. Go for it. Find the derivative. Find h prime of x. And rewrite your final answer with positive exponents. All right, what do we do here? What do we get? Go ahead, Eli.
I did -2
Mm-hmm.
times quantity x plus 1 to the -3
Good.
times 1.
Times 1. Good.
And then I did -2x plus 1. The quantity of that.
Say it again.
The quantity of -2x plus 1.
Negative.
2x minus 2. So
Ah, careful. Can you write -2x minus 2 to the -3rd? No, we can't do that here because this -3 is attached to the x plus 1. If this were not here, if the -3 were not there, then you could distribute the -2. But because this -3 is here, we cannot distribute this constant in there. Okay, so we cannot do that part. Okay, so tell me, what do we do from there? Yes, go ahead.
We multiply the 1 and -2.
So you get -2 times 1 is?
-2.
Mm-hmm.
And then x plus 1 to the quantity x plus 1 to the -3rd.
To the -3rd, good. So we multiply the -2 times the 1, we get -2, times the quantity x plus 1 to the -3rd. And then I asked you to give me the final answer with positive exponents. So tell me what we get. Yes.
-2 over quantity x plus 1
Raised to the 3rd power. Very good. All three of you. Very good. What questions do you have? Okay. All right. So, just to make sure you understand the rule, do part D. Part D says f of x is equal to 1 divided by x squared plus x plus 1 quantity squared. Find f prime of x. So what do we do? What do we get here? What did you do? Did you rewrite it first?
Yeah.
Okay, how did you rewrite it?
To the quantity x to the second plus x plus 1 to the -2nd.
Good. And from there, what'd you do to find the derivative?
Brought the negative two to the front, so negative two to the quantity x squared plus x plus one to the negative third
Plus 1 to the negative third, mm-hmm.
times quantity two x plus one.
Good. And then from there, what did you do? You can keep going or someone else can pick it up, whatever you prefer.
I took the quantity two x plus one
Mm-hmm.
and I times that by negative two, so I got.
So let's write that step in first. So you had negative 2 times the quantity 2x plus 1, and then what did you do? Did you leave? Go ahead. So you multiplied those two together.
Yes.
And did you multiply that by this quantity, or did you write it a different way?
So what I did was I just did that, so that I had negative four x
Mm-hmm.
minus two
Yes.
to the quantity x squared plus x plus one to the negative third.
Okay, so you'll have this times x squared plus x plus 1 to the negative third. And then what you said you did and got is negative the quantity. Bless you. Is that someone in here sneezing?
What?
Was that someone in here or outside? I didn't know because I hear people outside. This is just me having a moment. Like I hear and I think it's the people outside in the other room because I hear them so loud. So I'm trying to differentiate like who's speaking in class versus outside and then online, and it's just a lot to process. So thank you. There was nothing else behind that. I was just trying to figure out if it was here. Go ahead. So you have negative 4x minus 2, that quantity times the quantity x squared plus x plus 1 raised to the negative third. This weather has everybody it's a change in weather right now. Okay, so what did you do from here? That was good.
When you just, I don't know if this is right, but when you just have it be the quantity negative four x minus two over
Mm-hmm.
the quantity x squared plus x plus one to the third.
Yes, very good. Very good. That's your final answer. What questions do you have? What questions do you have? All right. Now, part E. You have g of x equals the square root of x plus x squared. How would you approach this problem? Yes.
Rewrite the original problem as the quantity x plus x squared
Raised to the 1/2, you got it. So you rewrite the original problem as the quantity x plus x squared raised to the 1/2. Very good. And now it's in a form where you can apply what rule? Chain rule. Go for it. Find the derivative. Find the derivative. What do you get here? Go ahead.
You want to start with the final answer?
Oh, the steps.
Steps.
You don't have to read prime in if you don't want to, but just the steps for sure.
Okay, so then you get 1/2,
Mm.
and then in parentheses, x plus x squared, raised to the negative 1/2,
Good.
times, in parentheses, 1 plus 2x.
Good. Very good. And then what did you do from here?
And then you multiply the quantity 1 plus 2x times 1/2,
Mm-hmm.
to get, 1/2 plus x, in parentheses.
You get 1/2 plus x. Okay.
And then you multiply that by the quantity x plus x squared raised to the negative 1/2.
Good. And
And then you can simplify that
as
as 1 plus x over 2 times the square root of x plus x squared.
say that one more time.
1 plus x over 2 times the square root of x plus x squared.
Not quite right.
Not quite right.
Not quite right going from this step to this step. How can we adjust that transition. Go ahead, you raise your hand.
Would we, in the numerator, 1/2 plus x?
Mm-hmm.
Now have the 2 and 1.
Yes, if you want to leave it in the form that you gave it, you would just write in the numerator. Where's the eraser?
Okay, I didn't know if we wanted, well, I didn't subscribe anyway, but I didn't know if we
You could write 1/2 plus x, not 1/2 plus, not 1/2 plus x, but 1/2 plus x.
And erase the 2.
Yes, but now I can't erase, go figure.
So we're allowed to
So,
with the fraction in the numerator?
hold on one second, why can't I erase? Oh, there we go. So you would have 1/2 plus x, and then you could, just a second. Come on. For 1 minute. And then we have this. So you could have 1/2 plus x over the square root of x plus x squared. That's one part. Alternatively, if you did not distribute, so this answer would be acceptable, okay? But if you wanted to rewrite it in the way that you were trying to initially, then what you should do is not multiply the 1/2 times the 1 plus 2x. I'm gonna give you an alternate step. So this, again, this is okay. That's sufficient. But you also need to be able to identify it as the following. From your first step, you could take this step, okay? Let me know if you have questions. You could just rewrite this as 1 plus 2x over 2, that's coming from the 1/2, times the quantity, the square root of x plus x squared. That's the alternate answer. Does that make sense? Either one is acceptable, but you need to be able to identify either. Typically, if you have a fraction involved as a constant, we don't typically write that fraction there in the numerator like that. We typically write it in this form. Okay? What questions do you have? Yes?
If you're doing the first way that we've done,
This way?
I wrote the denominator of the answer as x times the square root of x. Is that?
You said wrote this as x times the square root of x?
Yeah.
There's a difference. So I'm going to use blue here. So note that the square root of x plus x squared, so this is just an aside, this is not equal to the square root of x plus the square root of x squared. That's not true. That's what we call the freshman's dream. That x plus x squared here is stuck on the inside of that radical, so we cannot separate it. The only way we could separate things like that is if it were the square root of x times x squared, and that would be equal to x square root of x, because the square root of x squared is x. Does that make sense?
Yeah.
Okay. What other questions do you have? You all are looking tired. Let's do one more example though, okay? One more example. Last example I had planned is just for giggles. It's just to add more links to the chain to challenge you a little bit more. Why did your eyes grow so large whenever you saw this problem? We could do it still. Why are you shaking your heads no? Are you kidding me? How about do it for a bonus? Y'all are looking like I don't know about that. I'll extend the offer one more time before class is over, but we'll let part F be your last example, and G, I'll give you an opportunity, okay? R of x, F says R of x is equal to the quantity, square root of x plus 1, plus the square root of x cubed. You have that quantity cubed. Find the derivative. You said what? This is what? This one is not the bonus one. G is the bonus one because I wanted to make it a little bit more challenging. Wanted to make it a little bit more, just a little bit, by adding a few more links to it. Okay? So, R of x, we have, is this function. We want to find the derivative. So, here I'll write the primes in, just so you can see what's being done. Okay? So, you have 3, and why am I writing with blue and I'm writing with red typically? 3 times the quantity, the square root of x plus 1, plus the square root of x, raised to the 3 minus 1, which is what? 2, times square root of x plus 1 plus the square root of x prime. Okay? Now, we need to figure out how to take the derivative of this. Okay, so this is equal to 3 times the square root of x plus 1 plus the square root of x squared. And then we have to take the derivative of this. So just an aside. So an aside here, you can rewrite the square root of x plus 1 plus the square root of x as x plus 1 raised to the 1/2 plus x to the 1/2. Okay? So we're going to use the fact that we can rewrite that function that way, and we're going to differentiate it. So this would be times 1/2 times the quantity x plus 1 raised to the negative 1/2. And then we multiply by the derivative of x plus 1 because of the chain rule. And the derivative of x plus 1 is what? 1.
It's like a rule inside of a rule.
That's right. That's why I wanted to do this problem. What you've done typically throughout the examples in both of these sections, you wanted to rewrite it to avoid the rule, but I set this one up so you cannot do that. Okay? So, we have this, and then we're going to add to that plus 1/2 x to the negative 1/2, but we don't need the chain rule there, right? So we found the derivative. Does that make sense? Yes? No?
Yeah.
Okay, so let's rewrite the problem. So this is equal to 3 times the square root of x plus 1 plus the square root of x squared times the quantity 1/2 square root of x plus 1 plus 1/2 square root of x. This answer will be acceptable. You may also see a different answer. You may see the fact that these two have 1/2 in common. And if they have 1/2 in common, you can factor that out and multiply that by the 3. So you could rewrite that as 3/2 times the square root of x plus 1 quantity, or times the quantity square root of x plus 1 plus the square root of x squared times the quantity 1/square root of x plus 1 plus 1/square root of x. Either answer is acceptable. So again, to get from here to here, you would factor out 1/2, multiply the 1/2 times the 3, and that will give you this. Does that make sense? No, you said? Or yes? Okay, sorry. I heard no. Okay, so there you go. That's the chain rule. Now, go ahead. You had a question?
No.
Okay, so G. Part G. You laughing at my example. Don't do that. That's messy. So you have f of x equals the quantity 1 plus the quantity 1 plus the quantity 1 plus 2x to the third cube that, and then cube the entire thing. If you want to receive, how many points do I want to make it work? 4? 10? No way. No way. No way. 10 points to what?
I don't even know if you did.
No, I'll give you 5 points. 5 points. Huh?
Forgetting it right or trying?
For getting it right. Let's be clear. For getting it right. But let me say this. I do not want you to. So let me be clear. So do you see how we kept this and we didn't expand this and multiply all of that together? I want you to do this problem. Don't multiply everything together in the end and write out some ridiculously long answer, okay? What I want you to do, apply the chain rule and write down your final answer for the chain rule. Make sure you've applied it all the way. 5 points for the correct answer to be added to your quiz category in the end. Yes?
Do you foresee a potential quiz or test having an answer, a question, like as that?
I mean, it's fair game. It's fair game. Would I put this on a test? No. Right? Because, so, let me tell you, this is to prove a point that you can apply the chain rule to different things. And it's also to make sure you have good exposure and experience to applying the chain rule. That's the point of this kind of problem.
I'm overwhelmed.
You're overwhelmed, as most people are, right? Based on the reactions here. You're almost overwhelmed with this problem, but let me tell you this. On an exam, remember, what do I check for? I check to make sure you understand techniques, make sure you understand how to apply the techniques that you've learned, make sure you understand applications, right? This is just making sure you understand the chain rule a little bit more. I'm not going to ask you this nested kind of problem on an exam. So, do this. Have it for me on Thursday. You don't have to do it right now. Have it for me on, let me be clear, because I'm not going to collect the paper. I want you to take a screenshot of it or take a picture of your answer, and then I'll create a spot for you to submit it in Blackboard. Okay? Got it? Have a good one.